Hello, this is Kristen Spencer at WGU. I want to work with you today on some examples of operation preserving. The idea for operation preserving is to define a map or to work with a map that is defined and then to show that that map preserves the operation. In other words, the goal is to show that f of a dot 1 b is exactly equal to f of a dot 2 b, where dot 1 is the operation in the first set. So in this first example from page 217, we see that the first set is s defined under addition. So dot 1 becomes addition. The second set is t defined under multiplication. So both of these sets are the real numbers, but one operation is addition, dot 1, and the other multiplication, dot 2. And for operation preserving, that's completely fine to have two separate operations. Now we look at this map that goes from s to t, defined so that f of x equals exactly 2 to the x. In other words, whatever you give me as a real number, I'm going to give back to you as the exponent with 2 to the base. So I do a little scratch work here to convince myself that in fact this map is operation preserving. I start first with f of a plus b. Again, plus because plus is the dot 1 operation, the operation in the first set. I map this element a plus b to the exponent with 2 to the base, 2 to the a plus b. And then I observe, I know a little algebra here. I can apply a law of exponents to separate these as 2 to the a times 2 to the b. And that's about as far as I can go. So I jump to the other side of this goal, this f of a dot 2 f of b. And I look at what is that? Well, dot 2 is multiplication, because t is a set under multiplication. So I write that out, f of a dot f of b equals, and then I map that. Where does my map take the element a? Becomes the exponent with 2 to the base, so 2 to the a. Where does my map take b? 2 to the b. And I multiply those two. And then I notice this matches this. That's a great result because that was my goal, to show that if I operated in the first set before I mapped, I got to the same place as if I map the elements individually right away and then operate in the second set. Now that I've got these to match, I want to set up a formal proof. And to do that, I start here with my goal statement, work through the algebra as far as it'll take me, catch this place where it matches, and work back through these steps to get to this conclusion. It looks like this. F of a plus b is exactly 2 to the a plus b. That's just applying the map. I can do a little algebra now. 2 to the a to the plus b is 2 to the a times 2 to the b. And again, that's a law of exponents. That works for our real numbers. We're set under real numbers. And finally, I can look at that and say, oh, that is exactly where I would have mapped a, f of a. And 2 to the b is exactly where I would have mapped b, f of b. And look, those elements are multiplied, f of a times f of b. And that's my conclusion. That's my proof. It's a short proof, but understanding the scratch work that goes into the proof may be helpful. There's 2 other examples on this page. You're welcome to work those, or check out my next video and we'll work those together. Thanks for watching.